We are about to start the session, guys. Okay, guys. So now we are going to start the session. Let us start it. Yes, guys. So as I told you, yes, Janga, it will be for complete strength of material. Yes, Neeraj, good evening, dear. Sarath, good evening, dear. So please tell me, am I audible to you or not? Then we are starting the session. Okay, guys. So as I told you, this session is related to the preparation of Vizag. And for Vizag, guys, if you want to know the type of question they will ask in technical paper, you can solve GATE 1 mark problem as well as ESC and as well as ISRO problems. So these are going to be the well practiced, good practice material for this session. But I am taking the question from various resources, not only these one. Yes, Nitish, okay, it's fine. So guys, let us start the session with some very good questions. And this is some little introduction about me. I'm having 8+ years of experience, cracked gate many times with good gate score and gate rank. MTech I have done from NIT Bhopal, and I qualified GATE for the first time in my third year only. At that time we were able to give the exam in the third year. Now also from this year they have restarted again. I have written many research and review paper. You can find some of the paper in unpaid journal. You can find them on Google. And these are my areas of expertise, guys. So let us start the questions now. Let us see. This is the first question, guys. Shear center shear center given for this figure, this is some L section is there. Okay, so it is asked what is the correct answer out of these types of questions you can have, because they are directly formula putting, or you can say 1 mark type question. Hello Sai Kiran, hi K Siva Balaraja. Guys, please share this session to all the students, whatever they are in contact of you, because so that they can also get benefit of that. Because yesterday's session was cancelled due to various reasons. So please tell me the right answer for this. You need to find out the shear center for this figure. Yes. Fine, fine. Bhanurajan. Yes, dear. Definitely this session is useful for GATE as well as engineering services. Shri Kumar, good evening. Yes, dear, yesterday's session was cancelled due to various reasons. Prince, it's fine. Okay, you are giving the answer why. Sarath is saying C. Prince is saying good evening. Yes, good evening, Prince. Saurav Biswas is saying A. So, guys, for this question, the answer is B. Y is the correct answer. Good evening, Jay. Malai, yes, it's fine. Vishal, good evening. So, answer is not A, answer is B. When we are talking about shear center, guys, when we are talking about shear center, for shear center, there are two fundamental rules which are used. Yes, Sharmila Pali, good evening, dear. There are two fundamental rules which are used for shear center, and the very first fundamental rule for shear center is this one. That if you can see any cross section is given, and if any given cross section is symmetrical about any axis, if any given cross section is symmetrical about any axis, like let us say we are having this plus cross section. If for this plus section, this section is symmetrical about x-axis, so shear center will lie. Dear, this is used in civil engineering application. Okay, so when you see this plus section is symmetrical about x-axis, so shear center will lie on x-axis. It is symmetrical about y-axis, so shear center will lie at y-axis. So if you see, if any of the section is symmetrical about any axis, shear center will lie on that axis. So according to that rule here, shear center will lie at the intersection of these two. So this will be the shear center. Okay, guys, this is the shear center for this section. And the second rule for finding out shear center is, if you can see any of the figure is made up of two rectangles, then shear center lies at the intersection of those two rectangles. Like you can consider this to be one rectangle by which this plus section have been made. You can consider this to be second rectangle by which this section is to be made, and the intersection of these two is this point. So this point is the shear center. So guys, similarly, this L section can also be considered to be two rectangles. This is one rectangle and this is the second rectangle. And if you see these two rectangles are there, so the intersection of these two rectangles will be at this point, the center of this. So obviously this will be the shear center. So guys, if you are following these two rules, you can solve any objective question. Okay, if I ask you for some cross section, there is a cross section and I am asking you the shear center. I am giving you 4 points. This is A, this is B, this is C, and this is D. What do you feel? Where is shear center? What do you feel? Where is shear center? What will be your answer then? So guys, I am not only going to prepare you for the questions, I am giving you the concept rather than that, so that if similar question comes, you must be able to answer. Yes, Nitish, it's fine. Very good. Yes, guys, yes, Sharmila Palli, the answer is correct. Prince, answer is correct. B is the answer. Yes, Parth, Saurabh, Sri Kumar, Boina Rahul. Yes, fine guys. So let us move further to the next question. And yes, Dharani Krishan, yes, Boina Rahul, answer is correct for all of you. Here also on app also the students are attending the session. All of them you are correct also. Sarvan, yes, B is correct. So let us move further guys to the next question. This is from Torsion. A shaft PQRS is subjected to torques at PQ, R and S as shown in the figure. The maximum torque for the shaft in the section. So guys, you need to apply the method of section. In this PQRS, we can make various sections. These are section 1-1, section 2-2 and section 3-3. So you need to find out the torque in various sections and you need to answer the maximum torque out of them. So guys, apply the method of section and answer it. Don't worry, if you do not know the concept, then I am going to give you concept also. And you will not be able to solve only this question, but similar to that question you will be able to solve in any of the type. Can you repeat the second condition for shear center? Yes, Sri Kumar. The second condition for shear center is if some cross section is made up of two rectangles, like you can take this T section. This T section is also seems to be made up of two rectangles, then shear center will be lie at the intersection of these points. This will be the shear center. Okay guys, yes, this will be the shear center. Fine guys, so please tell me the answer for this. I am waiting for your answer. And also once again I am saying, please share this session to your friends who are preparing for BYJU'S so that they can be benefited from that. Okay, Partha is saying the answer is PQ. Okay, we will check it. Any other students? Okay, Jay is saying answer is D. Any other want to answer it guys? And guys, whatever the session we are going to take here, they are going to make you prepare for the paper. Similar question you will be having. Those students who have attended our NLC session, they have shared their feedback on Gradeup app that sir, whatever the questions you have done, similar questions was there in the examination. NLC sessions are still there in the YouTube channel. You can check it. Kalpana, okay, you are saying answer is C. Jeel Prajapati saying answer is D. Okay. Ramu is saying answer is B. So from you guys, all of the options you have given as the answer. Okay. Vishal Vaibhav is saying answer is D. Good Vishal. Okay, fine. Saurabh is saying answer is C. Let us see which one is the correct answer. Sachin is saying answer is C. So let us say what is the answer. Okay guys, first of all, you can see these torque. These torque, I am showing you the direction once again. For this direction is given. For this is the direction given. For this is the direction. For this is the direction. So you can see this P and S are in same direction. Q and R in the same direction. So if you see method of section says if you want to find out the torque at any section, you just see either left hand side or right hand side of that. Either left hand side or right hand side will give you the torque in that part. So when you see the left hand side of the section, the torque is T. So guys, for PQ, if you see T11 section, it is going to be plus T or minus T, whatever the sign convention you are using. Because in torque, there is no standard sign convention. So you can take it T, let us say, plus T I am taking. So T22, if you see the left hand side, the torque is T and 2T. T is in different direction, 2T is in different direction. So it will be T minus 2T. The answer will be minus T. If you see section 3.3, either you see left hand side or you see right hand side and take the algebraic sum of that. If you see T and T, they are in, T is in different direction, 2T and T are in different direction. So it will be T33 as equals to T minus 2T minus T. Guys, the answer will be minus 2T this time. So dear, you will say obviously magnitude wise 3 section is giving you highest. The answer will be RS. So Vishal, Vaibhav, Parth. Okay, you guys are correct. Very nice. Thanks Sri Kumar. So during all the examination, Gradeup gives this kind of sessions for you guys. So just attend them to get benefited. Question number 2 now, note 2, question number 3. Dear, these types of questions are more prominent, more important for your examination like Vizag or whatever the examination, NLC type of examination. But they are also useful for GATE 1 mark question for engineering services papers also. Okay. So please solve this guys and then give me the answer. K. Shiva Balaraja. Okay. You have given the answer as D. Okay. Fine. We will check it dear for sure. So guys, please continue this. I will be showing you a very good number and very good type of the questions. And if you will be attending regularly, you will be getting benefited of many sessions and complete strength of material I will be covering. All the topics I will be covering. Okay, J Kumar is saying answer is B. Ramu is saying answer is A. Once again, A, B and D have already been answered. Fine. Let us see if anybody also answer is C. A, B and D have already been answered. Fine. Let us see if anybody also answer is C. A, B and D have already been answered. Fine. Let us see if anybody also answer is C. A, B and D have already been answered. Fine. Let us see if anybody also answer is C. A, B. Yes, Dheeraj has given the answer B. Okay. Yes, Dheeraj has given. Parth is saying B. Sudhir is saying B. Arjun, good evening, dear. Okay, fine. Arjun, good evening, dear. Okay, fine. Arjun, good evening, dear. Okay, fine. I feel some echo is going on. Don't worry, I am working on that. I feel some echo is going on. Don't worry, I am working on that. I feel some echo is going on. Don't worry, I am working on that. Yes, guys, solve this question. I feel now echo problem is being resolved. Okay, I am solving this question, guys. I am solving this question. Don't worry. Good evening, Amaresh. Prince is saying A. Vikas is saying D. Sarvan is saying A. Yes, Vinay, now it's resolved. Don't worry. Now it's resolved. So a solid shaft of diameter D, length L is fixed at both the ends. A torque T naught is applied at a distance of L by 4 from the left, and as shown in the figure given below. The maximum shear stress in the shaft is. You need to answer that. Okay. So if we see that Arjun is saying A, Shaktivel is saying D. Okay. Vinay, now it's resolved. Don't worry. Sorry for the inconvenience. J is saying B. Let us see the answer, guys. A solid shaft of diameter D, length L is fixed at both ends. We will see this. First of all, you know this torque T naught is given to us. So as a reaction, here we will be applying a torque TA, and here we will be applying a torque TC. These are the reactive torques. Okay, TA and TC. Now guys, you know we can use the shortcut because complete shaft is made up of same material, and as well as the diameter is also same throughout. So we can definitely apply the shortcut. If you are going to write down the shortcut, TA will be given as equals to. First of all, you will be seeing that they are in opposite direction, so sign will be coming out to be plus. You will be writing the value of torque T naught. You need to find out the reaction at A. So you will see the distance of this applied torque from the opposite end C. This point is B. This is 3L by 4. Multiply it by 3L by 4 divided by total length is L. The answer will be coming plus 3 T naught by 4. Okay. And similarly you can write TC. When you will be writing TC, the applied load is T naught torque. So you will be writing here T naught, and again this and this, they are in opposite direction, so you will be writing the plus sign. The distance from opposite end this time is L by 4 and total length is L. So you will be getting it as T naught by 4. Yes, this is plus T naught by 4. So if you see that if the complete cross section is having same area, same J, so if you want to write down the shear stress maximum, it is given as basically T upon ZP. So if it is given as T upon ZP, ZP is same throughout the length. So the section in which torque is maximum, you will be getting maximum shear stress. So guys, if you see in AB and you are going to write the torque in section 1-1, you will write T11 left hand side, TA is acting, so you will say it is TA, and TA is nothing but 3 T naught by 4. So in this section it is 3 T naught by 4. And if you see in this section, it will be T naught by 4. Okay. So obviously 3 T naught by 4 is more. So you will be putting T to be 3 T naught by 4. And ZP is nothing but pi by 16 D cube. So you will be having 12 T by pi D cube. So B is the correct answer, guys. B is the correct answer, guys. Vishal Vaibhav, Prince, Jeel, all of you are correct. Saurabh Vishwas, all of you are correct, guys. It's very, very fine. It's nice, correct. So your answer is very much correct, guys. Yes, Kalpana, Pavan, answer is correct. Yash, answer is correct. Very nice, guys. So let us move to the next question. The next question is this one. Any doubt, please ask, guys. A torque of 1 Newton meter is transmitted through a stepped shaft as shown in the figure. The torsional stiffness of individual section of length MN, NO and OP. Now it is known as torsional stiffness K. Torsional stiffness is T upon theta. How it is find out? Like if I say this is a spring with stiffness S, I am applying a force P. So P will be written as S into X. Similarly, if we are having a torsional spring, guys, then we will be having T theta. Then we will be having T is equals to the torsional stiffness time. T is equals to the torsional stiffness times of theta. So guys, similar to that, as S can be written as P by X, S theta can be written as T by theta. So you need to find out the angular deflection between the end point M and P of the shaft. Okay, Rahul is saying answer is B. Answer is B. Okay. No dear Yasar, that's why the questions are of GATE 1 mark type or ESC type or ISRO type. Okay, means very less number of calculations will be required, not more than that. Okay, fine. Any other answers, guys? I am waiting for your replies. Okay, Pawan is saying it is 1, means D is the answer. Gundu Shiva is saying answer is B. Okay, fine guys, I am waiting for your replies. We will check it. You can see these are the shafts in series. This is shaft number 1, shaft number 2 and shaft number 3. And here you know that it is given that the torsional stiffnesses are 20, 30 and 60. So you are already given the torsional stiffnesses. This is 20 Newton meter per radians. For this it is given as 30 Newton meter per radian. For this it is given as 60 Newton meter per radian. These are already given to us. Okay, Prince have already answered. Yasser have already answered. Sharmila. Okay, all are saying answer is B. Okay, let us see. One student have answered it D also. Let us check it. So guys, these are the stiffnesses given already. You need to find out the angular deflection. So angular deflection between M and P, it is nothing but theta 1 plus theta 2 plus theta 3, because you know in series angular deflection will add. In series deformations are add up. So you know one thing, from here you can write theta is equals to T upon S theta. Okay, you can write it from this equation. So if I am writing this, torque in all the shafts, if you take section guys, you can see left hand side a torque T is applied, right hand side also a torque T is applied. So in any section if you find out T11, T22 and T33, torque is coming out to be same only, it is T only, it is T only, it is T only. So dear, we will be writing this is to be T1 upon S theta 1 plus T2 upon S theta 2 plus T3 upon S theta 3. You know it is 1 only, it is 1 upon 20 plus 1 upon 30 plus 1 upon 60. So guys, you will be having, yes, Jeel answer is correct. Very nice Yasser, fine. This is 3 plus 2 plus 1. So you will be getting 6 by 60. So answer will be 0.1. So guys, majority of you are correct only. The answer is B. Very nice guys. So okay, Pawan, yes, you have also corrected your answer. So those students who are on app and YouTube, please keep on giving answers. I am looking at your answers and your comments. This is a question from pure bending. Dear, when you see this question, not pure bending but bending stresses in beams, when you see this question, this seems to be a difficult one, but it is an easy question. Okay, when I will be solving this, you will say, sir, it is the easiest one. But this type of question you can expect in Vizag for sure. Guys, this type of questions are sure in Vizag. Okay, so just solve this question. Ramesh Mohan, hi dear. B is correct. Yes, your answer is very much correct. And guys, also refer this session to your friends also, so that they can also be benefited. Because if more number of students will come, more competition will be there and we will enjoy more and more. A cantilever beam of span L carries a concentrated load W at the free end. This is a cantilever beam. There is a load W at the free end. If the width of the beam is B and is constant throughout the span, then for the beam to have uniform strength, the depth at the fixed end should be equals to. Yes, this is the question. Ayush is already answered it. D is the answer here. F represent the stress, guys. F represent the stress. Yes, fine. Okay. Shakti Valley saying answer is A. So someone is saying A, someone is saying D. These two answer already we got. Parth is saying D. Okay. Yes, guys. So you know the expressions for bending stress is given as M upon Z. Okay, M upon ZNA. So guys, if you see this is the load W. So if you take a section which is at L distance apart at fixed end, obviously the bending moment coming because of this will be W into L. So it will be W into L. And ZNA is generally given as BD square by 6. So it will be BD square by 6. You need to answer the expressions of D. So if you want to answer it for D, you will be writing sigma B to be equals to 6WL upon BD square. Then D will be given as 6WL B, and stress is represented by F to the power 1 by 2. So answer D is correct. Very nice guys. Sachin answer is correct. Jeel answer is correct. Yasser answer is correct. Rahul answer is correct. Parth, correct. I feel Shakti well you learned now, and now I am looking at the app also. The students have answered. Kalpana, you are correct. Rohan, you are correct. Bhargav, you are correct. Jay, you are correct. Very nice, guys. Very nice. Okay, shall we move on to the next question? Thanks, Jeel, for your wonderful words. This is the next question from bending only, guys. And these stresses are given as this is kg per centimeter square. This is kg per centimeter square. 10 centimeter, and this is given that the distance of this from the top fiber is n, and you need to answer the value of n. Very good, Prince. I feel you have already answered it. D. Okay, fine. Waiting for others to reply for this. J. Kumar, very nice, dear. Your answer is correct again. Gundu Shiva, answer is correct. Fine. Yes. On YouTube also, guys, I am waiting for your response. Shubham, answer is correct. Rohan, answer is correct. And guys, I will also suggest you must download the Gradeup app. There every day 3 to 5 series of questions are going on for free. For GATE, for engineering services, for all the examination. Okay, if you join them, they are free of cost, obviously, so you can learn a lot from that. Ayush, answer is correct. Sudhir, answer is correct. Dharni, answer is correct. Prince, answer is correct. Parth, answer is correct. Shaktivel, answer is correct. Ramesh Mon, it is correct. Very nice. So dear, there you can solve it in two ways. One is bending stress is directly proportional to y. How we know that? Because the expressions are sigma b at any fiber is my upon INA. This we got from the bending equation. So dear, sigma b is directly proportional to y, so you can write it sigma b top to the sigma b bottom. You can write in this way, and you can see that this is y at top to the y at bottom. Sigma b at top is 800, sigma b at bottom is 200 if I write only magnitude. Y of top is n, y of bottom is 10 minus n. This will give you n to be 8 centimeters, guys. So answer is D for sure. Let us see the next question, guys. So this type of questions are only part of this kind of examination. Yes, guys, this question is from compound beam. This time two beams are joined in series. Compound beam. So solve this question, guys. This is a wonderful one, and I have given you all the part related to that. Yes, okay, Neeraj, you have answered as A. Let us see whether your answer is correct or not. Okay, Sai Kiran Kalpana, for previous question your answer is very much correct. Yes, very nice. Dharani Krishan, we can solve it using trigonometry also. Definitely we can solve it using trigonometry. Yes, guys. Prince is saying answer is C. Okay, very nice, Prince. Jay is also saying answer is C. Gundu is saying answer is C. Fine, guys, we will be just checking. Parth is saying answer is C. Sudhir Goru is saying answer is C. Rohan Raj C. Yes, Sudhir, Dharani, Krishnan. Yes, fine. So let us solve it, guys. So you know that this kind of beam is solved in this way. We just break this beam into two parts, and as you know, this is a hinge. This is internal hinge, and it acts like hinge support only. So you can assume it to be hinge support. But at this point there is no force. So this condition needs to be maintained always. So guys, you know one thing, that if you are dividing it into two beams, one Q will be giving some reaction RQ. So obviously this beam will be stable if there will be some reaction because of that hinge support. RP will be coming. But at this point P, the net force is 0. It will be 0 if we apply the same force in opposite direction on the second beam. Now the net force on the P is going to be 0 only. So guys, now if you see the reaction part, here you will be having the reaction that is equals to vertical at O, this will be horizontal at O, this will be moment at O. So you need to answer about the moment at O. So if you see this beam, this is RP, this is RP. This load is acting 10 kilonewton. So obviously this is acting in at mid span. So obviously we can write RP is equals to RQ is equals to 5 kilonewton. So if we get this value, so RP will be 5 kilonewton and this distance is 2 meter. So the bending moment MO will be equals to this 5 into 2. It will be 10 kilonewton meter. The answer will be C, guys. Very nice, guys. Ayush, Vishal, Vaibhav, Jheel. Answer is correct. Yes, you're welcome, Ramesh Mohan, and thanks for your wonderful words. Let us see the students on app also. Shubham, the answer is correct. Sai Kiran, the answer is correct. Neeraj, answer is correct. Fine, guys. All of you are correct. Let us move further. Yes, Kalpana, your answer is correct. This is the next question, guys. The part of the shear force diagram for a beam is shown in the figure. Mind this, part of shear force diagram. It is not the complete beam. Part of the shear force diagram is given. If the bending moment at B is minus 9 km, this is point B. So it is given that bending moment at B is minus 9 kilonewton meter. Then find out the bending moment at point C. You need to find out the bending moment at point C. Yes, dear. Very nice. Fine. Yes, and guys, please like this session and also share with your friends. Ayush Sachan is giving the answer as 40 and I feel you are correct. Let us check it then. Waiting for others to answer. Let us see on app whoever is answered. No one is answered yet. Very good. Sudhir is saying A. Shaktivel is saying A. Yes, on app students, please answer it. And here don't leave this session in between because you will be learning a lot of concept in this session. Prince is saying answer is D. I feel Prince, you need to recheck it. J Kumar is saying C. Kalpana is saying A. Yes, Yasser, answer is A. Vishal Vaibhav, answer is A. Fine, good, good. Okay guys, now I will solve it because that much time is enough to solve this. Dear, you know that the relation between shear force and bending moment is like that. I can write bending moment at B minus bending moment at A to be area of shear force diagram. Area of SFD between A and B. Yes. You always write right hand side point minus left hand side point. Always this. Why? Because we consider X is positive in this direction. So if we consider X is positive in this direction, so obviously we will write MB minus MA. So when you are going to write MB minus MA, you know that MA is, if nothing is mentioned, you will assume to be MA is equals to 0. Okay. But you need to answer the bending moment at C, I feel. And bending moment at B is given as minus 9. So I need not write MB minus MA. I must write MC minus MB. And MC minus MB will be area of SFD between B and C. So this is the area of this triangle. And if you see this area of triangle, it is half into 14 into 7. Okay, this will be the area. It is going to be 49 kilonewton meter. And you know MB is already given as minus 9. So MC minus of minus 9. So MC will be 49 minus 9 will be 40 kilonewton meter. Answer is A for sure. Yes, Junaid Ali, your answer is correct. Very nice. Yes, dear, it's fine. Yes, Neeraj Kumar, answer is correct. No, Safi Akhtar, answer is not correct. I feel now you got the solution. You can see Rohan Raj, answer is correct. Let us see the next question, guys. This time, once again, it is a compound beam. Let us see how many of you give the correct answer for this. Compound beam means beams in series, like bars in series, shaft in series. This is beams in series. Yes, fine guys. So I really hope you guys will do wonder in the Vizag paper because your preparations are very nice because majority of you are giving the correct answers. So I'm happy with that. And guys, yes, this series is going to be continued daily Today we are discussing strength of material. One more session will be there for strength of material on Sunday on some different time that will be notified to you with the help of some story or the notification, or you can check it tomorrow, it will be given. And day by day different subjects will be covered by the complete entire team of Gradeup Mechanical. So do not miss any of the session. You will be getting a lot more the types of questions. Sarath Lal have answered it 10, 10 and 0. And I feel the answer of Sarath Lal is correct. Junaid Ali is saying A. Good Junaid. Okay, here also answer came from Dheeraj. It is okay. Kalpana is saying A. Gundu is saying B. Okay, Gundu, you can have a look over that once again. Check it. Jay is saying A. Okay, very nice. Waiting for others to reply. Then I will solve. Sudhir Goru is saying A. It's fine. Correct, dear. Rahul is saying A. Yasser is saying A. Prince is saying A. Saurabh is saying A. Neeraj is also saying A. Dharani Krishnan. Okay, A. Sarvan Kajle A. It's fine. Great. Satya Prakash A. Where yes, Shakti A. Rahul A. Now let us solve it, guys. So first of all, dear, this is the point of internal hinge. This is an internal hinge. And I would like to tell you, when I teach you the compound beam, I always calculate it and also derive it, that bending moment at internal hinge is always coming out to be 0. In other words, this is nothing but this is the point of contraflexure. This is the point of contraflexure. Here bending moment is 0. So there is no need to solve this because only one option is there at which bending moment at C is given 0. So option is A. There is no need to check all these options. Okay. And if you are going to find out still the bending moments, first of all you need to find out the support reaction. Then after finding out the support reaction, then you will check bending moment at A, bending moment at B and bending moment at C. Then also you will get the answer to be 0 only. So answer remains the same. Okay, so about internal hinge bending moment is 0. So it is also known as point of contraflexure. So dear, okay, I ask you, this beam is, what about this beam? This beam is statically determinate or indeterminate? Statically determinate or indeterminate? Because this question have been asked in various examination many number of times. So let us check whether you know this or not. Is it a statically determinate beam or indeterminate beam? Okay, first let us check your basic of that. Thanks Ramesh Mon. Dear, at D, when you will be checking it, for that you need to find out the support reaction first. So if you get this support reaction, then I can tell you. So if you find out the support reaction by assuming it to be simply supported beam, then you will be getting 10 kilonewton. So if you find out the bending moment at D, what you will be getting, I am telling you. You will be getting this 10 into 4. 10 into 4 minus 10 into 3 minus 10 into 2. So it will be 40 minus 30 minus 50 will be minus 10. Yes, it is correct. Okay, dear, majority of the students say it is statically indeterminate. And why they are saying? Because they are very much innocent. They are innocent because they feel one reaction is this 10 kilonewton, one reaction will be coming here, and that will be one moment is also there. No horizontal force, no horizontal reaction. So if we leave the horizontal case, we will be having two equilibrium equation, summation vertical 0, summation moment 0. So there are two equations, but there are three unknowns. One is vertical D, one is moment D, one is vertical, let us say vertical Q. So they feel that there are more than two unknowns, so it is statically indeterminate. Guys, but you forget there is an internal hinge also. And when you will be using internal hinge, then dear, you will be getting all the answer by using these equations. So this is a statically determinate only. Yes, because without using this internal hinge, you are saying it is statically indeterminate. But once you will use this, it becomes statically determinate. Okay. So I am telling you, Dharani, the difference is if the number of unknowns, are more than the number of equations, then it is statically indeterminate. And if the number of unknowns are less than or equal to number of equations, it is statically determinate. So dear, if you see in this beam, you are having unknown 1, unknown 2 and At the same time unknown 3. So unknowns are 3, and equations are 2. That's why you said it is indeterminate. But guys, you have not used the equation of the internal hinge. If you use the internal hinge, then only we have divided this beam into two beams. One is cantilever and other is a simply supported beam. So when you will be divided into two beams, this is statically determinate, this is statically determinate. So the combination will also be statically determinate. Why? Because you have not used the concept of internal hinge. Internal hinge will be producing a reaction here, at the same time a force here, because net force at this point of joint is going to be 0. Hope you guys got it. Yes, Bakri bhai, it's fine. Yes, it's correct. Okay. This type of questions are basic only. We cover these in the class. Okay. Just try to understand my point. You have discussed the compound bar. You say it is easy. You discuss the compound shaft. You say it is easy. And they come in all the examination. So why not compound beam? All of them comes in examination. You can see these are previous year's question of some of the examination only. They are not the question which I am arbitrarily taking. These are the question from some of the examination only. Okay. Solve this question. Let me yes, statically determinate. Dheeraj, Sudhir, your answer is correct. Sai Kiran, Dheeraj, Sudhir, it's fine guys. Solve this question. This is a wonderful question once again. Yes, the beam ABC shown in the given figure is horizontal. The distance of the point of contraflexure from the fixed end A. You need to find out the distance of point of contraflexure from this point A. You can solve this question. This reaction already is given to you. You need not to find that. RB is given to you. Very good guys. Solve this question. And this is going to be helpful to you. GATE 2021 also. This will be helpful for BYJU'S also. This will be helpful for ISRO paper as well as engineering services examination. All such papers like BARC, these types of questions are, yes, required. But for GATE, they are 1 mark question, not 2 mark questions. Yes guys, please like this session and also share with your friends so that other can also be benefited. And this series will continue for daily till your examination up to 13th December, because I feel that is your exam day. Till that point, every day you are having the session on this. So please join daily. The session time is 7 p.m. and daily there is one class on YouTube. You need to attend it. Yes, nice guys. Please solve this question. And here we will cover it for all the subjects. Sudhir is saying answer is D. And guys, also I would like to say you must download the Gradeup app. Their majority of the series now are going to be started for GATE 2021 as well as for 2022. They are for free. Okay, like I am going to start engineering mechanics series within 2 to 3 days. So you must join that. You will be knowing the fundamental concepts which will be helpful to you for GATE paper. Prince is saying D, Ramesh Mon is saying A, 0.33. I will be telling you Ramesh Mon. Just wait. Okay, fine guys. Let me solve this in that case. Okay, on app also let me check what is the answer people are giving. Kalpana is saying D, Neeraj is saying D, Sudhir is saying D, Sai Kiran is saying D. Let us check it guys. Let us check it. So dear, first of all, you know, as in this beam there are two forces, 5 kilonewton, 8 kilonewton. Wherever the force changes, the section changes. We will be having one section here, that is section 11, and second section here, that is nothing but section 22. So there are two section 11 and second section is 22. So dear, if you want to write down the bending moment equation at section 11, it will be, you know that if this distance is x, you know the sign convention for sagging and hogging. This is the positive moment and this is the negative moment. So this is sagging, this is hogging. So dear, if you take the bending moment at 1 1 section, it will be minus 5 into x. and bending moment at 2 section will be minus 5 into x plus RB into, this is x minus 0.25. You can write it minus 5x plus 8 into x minus 0.25. It is, you know that if you use this equation, you will get bending moment to be 0 at x is equals to 0. This is the end C. So obviously for point of contraflexure only bending moment 0 is not the required condition. Okay, Shyam Kiran, I am solving, just wait for a minute, I am giving you the answer. Yes, so guys, as for point of contraflexure, it is not the condition required only that bending moment should be 0. There is one more condition, that bending moment should 0 and also it should change the sign. But at C it is not changing the sign. So guys, when you solve it, the second equation, and you put it to be equals to 0, you will be getting minus 5x plus 8x minus 2 is equals to 0. So you will be getting 3x to be equals to 2x to be 2 by 3 is equals to 0.66. But guys, this is not the correct answer because this is the distance from C. But you need to answer the distance from A. So the answer will be 0.333. A will be the correct answer. Yes, Sharmila, your answer is correct. Yes, fine. So guys, regularly 7 to 8 is the time for this series. If you are going to continue this series, your preparation will be going to be foolproof level for Vizag, guys. And Gradeup always provide these kind of sessions for all the examination on app as well as on YouTube. So guys, those students who have attended NLC, they know how useful the sessions were. So you must also attend these sessions and also download our app to learn more, because on app every day 4 to 5 sessions are there for free by entire faculty team of Gradeup. So you can join there. Regular sessions are going on for GATE, engineering services, ISRO, DRDO, various examination. Even XC paper Gradeup is preparing. Gradeup is going to prepare you for. Generally students are not getting the option to prepare for XC at any platform, but Gradeup is providing you that. Okay, even many sessions are free of cost. You can join them also. Saurav, actually yesterday's sessions was basically stopped from the studio side because there was some network error going on, as that's why we have rescheduled that, and second session of SOM now will be on Sunday. Okay, Sunday I will be taking the second session and that will be the session. Yes, Yasser, you can do the previous question by SFD, but why to use difficult method if we are having the easiest method? Answer this question. Ayush is already answered it C, and I feel Ayush is saying Junaid Ali have answered it. So there are some students whose preparations are very good. Those are giving the right answer for all the questions. Yes, Sudhir Guru, Neeraj, answer is C. Very nice, guys. Very nice. Waiting for others to answer. And guys, not only that, if I tell you we are starting, we have already started the crash course for GATE 2021 on YouTube, and already I have taken many sections for strength of material. HMT is already been over. Now we are going to continue that. Now I will be taking the session for Tom, and also deflection class is pending, as you guys have requested me to take a long session over deflection. We will be taking that. Don't worry about that. Yes, fine, guys. So regularly join us at 7 to 8. One time is there. Okay. 8 to 9 is the time on AEJ channel on Gradeup Gate, Gradeup YouTube channel. And after that, GATE session is also there. Every day. Very nice, guys. Sarath Lal, Prince, Yasser, Mickey, Swami Ranjan Sahu. Okay. Sri Kumar, C. Okay, let us see. So dear, this is a bending moment diagram given. And X you need to answer. You can see here there is a jump in bending moment diagram. And that jump is equal to 1000 Newton meter. If this is a jump, yes, Dharani Krishan Sai, it is correct only. If this is the jump, there will be a moment. Okay, if we have the jump in SFD, we will be having the shear force or vertical load. So X is a bending moment of 1000 Newton meter. This question may become very a good question if they give the direction of bending moment also. Okay, so then this question will become more useful. So on app also, Rohan, J Kumar, all of you have given the right answer. The next question is this one, and here I am asking you the support reaction at B and E. You need to tell me the support reaction at B and E, VB and VE. This is a universal question for all the examination. It have been asked in civil engineering, ESC. It have been asked in mechanical also, ISRO once. It have been asked in DRD also once. This is a universal question. This have been asked nearly in all the examination. So guys, such kind of question you shall never leave. Okay, that's why we are doing this. Okay, yeah sir, that's fine. Yes, answer it guys. This is a good question. Sudhir is saying answer is 0. Neeraj is saying answer is 0. So guys, please like this session and share with your friends so that others can also be benefited from this. Okay. So dear, when all the moments are acting, so for this case, we will be writing VB and VE if you want to find out. The support reaction, you know, first of all, VB plus VE, there is no vertical force, the summation is 0. So VB will be equals to minus VE, that is for correct. And this is given as plus minus net moment divided by total length. Okay, so we will see net moment. This is 6 in this direction, 8 in this direction, 4 in this direction, 2 in this direction. I feel 8 and 2 are in same direction, 6 and 4 are in same direction. So it is 6 plus 4 is 10, 8 plus 2 is 10. So net moment is going to be 0. So obviously VB barabar minus VE is equals to 0. Very nice guys, all of you have answered it correct. Yes Ayush, Shri Kumar, Yasser, Jake, fine. This is the second question, and here you need to answer the maximum bending moment in the beam. Find out the maximum bending moment in the beam. Yes dear, find out the maximum bending moment in the beam. I am waiting for your answer. Yes dear, solve this question. So dear, we need to prepare the question as per the examination. If this would have been gate 2 marks problem, these are not of that level. But according to the examination, we need to select the question for you guys. Because in this examination, the level of question will be this only. Okay. Okay, Jay is saying 8, Sudhir is saying 14. Parth is saying 6, Yasser is saying 6, Ayush is saying 6. Neeraj is saying 6. So dear, for that you need to apply the method of section. You know this reaction is 0, this reaction is 0. So we will be taking the section guys, and those section will be taken like this. One section I will be taking here. This is 1 1. Second section will be this. Because reaction is 0, you can take it here, but it is not useful. It is 2 2 session. Then it is 3 3 because reactions are 0. If you see for section 1 1 M11, this is creating the sagging moment like this, because this is positive moment and this is negative moment. So you will be writing it to be plus 6. Then when you will write for M22, it will be plus 6 minus 8. It will be minus 2. If you write for M33, it will be plus 6 minus 8. Plus 6 minus 8 plus 4. It will be plus 2. So the highest value is plus 6. We will see magnitude wise. This is my plus 6 kilonewton meter is the correct one. So many of you have just Jeel, your answer is correct. Dharni correct. Prince correct. Anurag, good evening dear. So I would like to tell you guys the time of this session is 7 p.m. So you can join regularly at 7 p.m. on this YouTube channel. Yes dear, this is the question where bending moment diagram is given and you need to answer about the shear force at section AA dash and BB dash. Yes, Mr. Yasser, you are very much correct. Okay, Kalpana, yes. I feel Raj Shekhar, Sudhir, you got the mistake. Yes, guys. So, daily join us at 7 p.m. for this special series, which is for YJU'S, and we will continue at 9 p.m. We are running another series for gate crash course. Okay, these two series are going on YouTube channel and on app, Gradeup app. You can see MSQ free session of mine by just download the Gradeup app. Follow me there. You will be getting MSQ session for free. You can prepare it for GATE 2021. The level of question is very good. Ayush answers okay C. Sarath is saying C. Yasser is saying C. And your answers are correct, guys. Jay Kumar is also saying C. Very nice. So those students who are giving the correct answer for all the question, definitely guys, you are going to be selected. And others also try to work hard. And dear, when you are going for this bending moment diagram, we know that slope of bending moment diagram. Slope of bending moment diagram is nothing but the shear force. So if you want to write down the slope of bending moment diagram, this is shear force. So this is a horizontal line, है ना? This is horizontal line and this is inclined line. So if you check the slope of bending moment diagram, if it is shear force, you know horizontal line means the slope is 0 basically. The angle with x-axis is 0. So the slope is also written as delta y by delta x. You can see from this to this distance, change of y is 0, so slope is 0. So either B or C will be correct answer. Then if you see this, you can see this distance is 2 meter. In this 2 meter distance, the change of y is 100. So if you want to find out this is 100 by 2 will be 50. So the answer will be C in this case. Okay. So answer will be C in this case 0, 50. So many of you have given correct answer. Junaid, Prince, Ramesh Mon, Prince, Parth, Ramesh Mon, okay. Shubham, Rohan, Jay. Let us see the next question, guys. This is from thin cylinder. The question is from thin cylinders. Solve it, guys. A thin walled cylindrical pressure vessel having a radius of 0.5 meter and wall thickness of 25 mm, subjected to a pressure of 700 kPa. The hoop stress, it is given as PR by T or PD by 2T. Find out the answer. Mumtaz, hello. Somik is saying C. Okay, you are saying if parabola. Dear, if it will be parabola, then you cannot find out the slope directly. Okay, then you must know the equation of the parabola. Without knowing the equation, you cannot solve it. Okay, then this is not the way in that case. Or they will give you the equation for that. Ayush is saying A. So sigma hoop is 700 kilopascal into radius is 0.5 meter. divided by 2 into 25 mm. 25 into 10 power minus 3. This is into 10 power 3. Okay. Hi Amit. Okay. Morshid is saying answer is to be A. Okay, it is 14 MPa guys. A is the answer. Fine. On app also, students have answered. Dheeraj, your answer is correct. Next question is this one. This is a wonderful question. Yes, Parth, Mukul, Shaktivel, Junaid, all of you are correct. Now solve this question. This is a wonderful question from thin sphere. This is a question from thin sphere, guys. Morshid is saying B. Amit, this is the class going on for Vizag. As Vizag paper is there on 13th and 14th December. This is for mechanical engineers. The class is going on. And we are going to have this class regularly. 7 p.m. R is not diameter, R is radius. Ayush is saying the answer is D, and I feel Ayush you are very much correct. Yes, Shubham, you are correct. Shubham, you are correct. Yes, Saratlal, Ayush. The answer is D for this case. I am telling you how to solve this. A thin walled spherical shell is subjected to an internal pressure. Okay, let us say the pressure is P. Very good, Parth, Junaid. If radius of the shell is increased by 1%, it increases from 1 to 1.01 times of R. Internal pressure remains the same. The percentage change in circumferential stress, thickness is reduced by 1%. It is 0.99 times of T. So dear, you know that the hoop stress is PR by 2T for sphere. So it can also be written as PR by PD by 4T. So as we are knowing the radius, so this is the hoop stress PR by T. The new hoop stress is P, radius is 1.01 R divided by 0.99 times of T. So you need to find out the percentage change. This will be sigma h dash minus sigma h. Okay, divided by sigma h, you will be having into 100, 2.02%. So the answer is D. Yes, guys. Okay, no issue, Amit. Yes, Rohan Raj, Neeraj Kumar, answer is correct. Okay, guys. So this is the last question for today. We have solved today the question from SFDs, BMDs, shear center and thin pressure vessels. For the other topics we will be solving on Sunday. The time will be mentioned or given to you tomorrow for that session. A thin cylinder of inner radius 500 mm. Thickness 10 mm. Pressure 5 MPa. You need to find out the hoop stress. Easiest one, guys. It is PR by T. Pressure is 5. It is 500 mm is 0.5 meter. Thickness is 10 into 10 power minus 3. It will be 250 MPa. B is correct. Thanks, Rajalingu. Yes, Rohan Raj, J, Neeraj, B is correct. Shubham, B is correct. Yes, guys. So I would like to tell you guys two things. One is join us daily at 7 p.m. We are having the session related to Vizag. Also join us on Gradeup app. On Gradeup app, regularly 4 to 5 series for free are going on. This is for various exams like GATE, engineering services, various examination. Okay, guys. Yes. And you can follow me there if you want to see the MSQ session taken by me. There I have framed the question by myself. If you will join this session, you will be in love. As well as if you want to prepare for interview on YouTube channel of Gradeup, just search for the interview session for ISRO. I have taken many sessions and you will love the concept I have mentioned there. This is my promise to you. So just see once those sessions. Your concept will be crystal clear after knowing them. Yes, Dharani, it's correct. Okay, fine guys. Fine guys. So tomorrow you will be knowing the time for the second session of SOM on Sunday. Okay guys. So join the second session tomorrow on this channel as well as on app. Okay guys. And if I tell you one thing, that some information about the Gradeup courses I am giving you in this last minute, guys. These are the various courses right now going on Gradeup. Now Gradeup is providing you the subscription model, where just by subscribing you can have the access to various courses. We are running a Gear Up course which is for GATE 2021, Rank Up course which is the practice question, and here we are going to practice a number of questions, 3000 plus in 300 plus hours. This is ideal for those whose preparations are already done, only they want practice. This is for those students who want the concepts also, and this is for Vision 2022 for GATE ESC 2022, as well as the syllabus in this batch will be completed for engineering services before the paper of 2021 ESC also, as the paper is rescheduled. You can join other batches also, MSQ batch is there separate. So guys, majority, whatever the batches are going on, all of them you can access only with one subscription. Okay. Yes, you are welcome, Somik. This is our faculty team, guys. So you can see all of these, and you can see our free sessions, our app, our interview session on YouTube. By looking on those sessions, you can judge that the quality you are going to get on Gradeup. These are our ranks. Okay guys, and this is a green card where you will be getting the test for all the papers like Vizag, GATE, engineering services. One card can give you the test series for all of the examination. This is the unique concept of Gradeup which no other coaching is providing. Okay guys, yes, and these are related to the subscriptions. Okay, you can search it because various discounts are also going on. You can call to this number, and thanks guys for joining me. Goodbye for this session. We will meet once again on Sunday for other questions. Goodbye guys. Thanks for joining. Thanks for joining once again guys. Okay, fine guys. Goodbye. And please like and share the session while leaving. Good evening, Charles. Actually, this is the end of the session. You can join us 7 p.m. tomorrow now. Every day the sessions are going on for Vizag. We are going to take that. It is helpful for GATE, ESC also. Okay. Good night, Jay. चार्ल्स, मैं ये बोल रहा हूँ कि these sessions are, ये सेशन जो है वाइजैक के लिए है, ये गेट और इंजीनियरिंग सर्विसेज के लिए भी यूजफुल है, तो आप कल शाम को 7 बजे ज्वाइन कर सकते हैं इस सेशन को. ओके, गुड बाय फॉर द टाइमिंग डियर. दिस इज द एंड ऑफ द सेशन एंड थैंक्स फॉर ज्वाइनिंग गाइस.